more mix up. Okay, I'll read a question. A certain mass of calcium carbonate chunks is added to a hydrochloric acid solution in an open beaker on a scale as shown here. The equation for the reaction is calcium carbonate plus hydrochloric acid gives you calcium chloride plus water plus carbon dioxide. Carbon dioxide is allowed to escape. So because the carbon dioxide is allowed to escape, it's called an open system because the chemicals are not kept within one place, all right? The table below was obtained for a time interval of 7 minutes. So let's look at this table. You start at 0 minutes. The mass of the beaker and the contents is 200 grams. Then after 1 minute, the mass becomes 180. The mass becomes less. Why does the mass become less? The mass becomes less because something was allowed to escape. The carbon dioxide is allowed to escape. All right. At 2 minutes, it's 165. 3 minutes, 155. 4 minutes, 148. 5 minutes, 144. 6 minutes, 144. 7 minutes, 144. So the grams went from 200 to 144. All right. So the first question is, explain the term reaction rate. What is reaction rate? I hope you're writing answers. What is reaction rate? The reaction rate will be the time, the speed at which the reaction takes place. The change, look at the answer, the change in amount of mass, volume, acceleration, concentration of products formed per unit time, right? The change in the amount of substances per unit time. So the speed at which the reaction takes place, all right? Question 2 says, calculate the change in the mass of the beaker and its contents during the 7 minutes. So how much did the mass change? It was 200 and in 7 minutes it was 144. So what was the change? So to work out the change, it will be 200 minus 144 and that's going to give us 56 grams, correct? Okay, so that will be 56 grams. You just subtract it to see how much the grams got less with time interval. Why did the grams get less? Because the grams got less because the carbon dioxide was allowed to escape. All right. Number 3, use your answer to question 2 to show the average reaction rate during the 7 minutes. So what's reaction rate? The chemical used over time, isn't it? So how much chemical was there used over time? So to do that answer, we'll say reaction rate is equals to change in mass over time taken. So the change in mass was 56 and your time taken was 7. So how many times are 7 going to 56? 56 divided by 7, which will give you 8. All right. So the change will be 8 grams. And then your time will be 56 over 7 will be 8 grams per minute because your time was in minutes. Sometimes it's in seconds. You must see the question, what they ask. Question 4. Calculate the mass of calcium carbonate which reaction during the 7 minutes. The mass of calcium carbonate, this is important. All right. What do we have? If you look at question 3, we worked out the rate of the reaction, and what we can do there, we can calculate the mass of what in question 3? The mass of the gas that was released. And the mass of the gas that was released in question 3 will be carbon dioxide. But the question is, calculate the mass of the calcium carbonate which was released. So this is the stoichiometric section we did last year, right? Stoichiometry. So how do you do that sum? What do we have? We got carbon dioxide And we worked out in the sum before the mass of the carbon dioxide. So can we work out the number of moles of carbon dioxide? So work out the number of moles of carbon dioxide that was released. So number of moles is equals to actual mass over molar mass. The number of moles will be, the actual mass will be 56, isn't it? And your molar mass of carbon dioxide will be 12 plus 16 plus 16, which is 44. 44. So 56 over 44 will give me 1,272 whatever. So you round off to 2 decimals. So it will be 1,27 moles. So now we got the moles of carbon dioxide. But what's the question? The question says we want to work out the mass of calcium carbonate. So what do we do next? After you work out the moles, when you do stoichiometric reactions, what do? If we know the number of moles of carbon dioxide, we can deduce the number of moles of calcium carbonate. So what's the number of moles of calcium carbonate? It will be 1:1. So we got 1,27 moles of carbon dioxide. So that means we got 1,2 moles of calcium carbonate. So we got a mass of calcium carbonate. Let's see how this is going. We got a 56, we got a 1,27. The mole ratio is 1:1. And we can say that's what we've got, right? Therefore, the number of moles of calcium carbonate will be 1,27 moles because the mole ratio is 1:1. Now that we've got the number of moles of calcium carbonate, and we can work out the molar mass of calcium carbonate, which is, work it out for me. It will give you 100 grams per mole. We can work out the actual mass of calcium carbonate that reacted. So number of moles is equal to actual mass over molar mass, all right? And the actual mass is 127. The actual number of moles is 1,27. Actual mass is what we want to find over 100, which is the molar mass of calcium carbonate. And you get 127 grams, correct? So that will be how you work out the grams of calcium carbonate that reacted in 7 minutes. Number 5. Why is the mass of the beaker 144 grams for 5 minutes, 6 minutes, and 7 minutes? Why did it stay at 144? Why didn't it get less or more? Why didn't it change? Because it started off 200, all of a sudden it's 144, now it stays at 144. Why is the mass of the beaker constant at 144? It's because one of the reactants have been used up, all right? And most probably in this case, the reaction, go to this reaction and you will see that what has been given off will be, if you go to this reaction, we'll see that the substance that has been used up will be the most probably the calcium carbonate. So that the chalk, for example, putting it in simple terms, the chalk was put into the acid, the chalk got finished, right? So the calcium carbonate got used up in the acid. Most probably that will be the most obvious answer. So that's why it stays at 144 because the reaction is complete, because there's no more reactants to react. All right. And then one of the products formed in a chemical reaction is a gas. Which one of the following graphs of volume versus time best represents the formation of this gas until the reactants are used up? So if you look at the gas at the beginning, if you work it out from here, if you look at this graph, which graph best represents the amount of gas of carbon dioxide released? If you look at in the first interval, 1 minute, 20 was released, then 15, then 10, then 7, then whatever the case is. So at the beginning there was no carbon dioxide, then a lot was released, and then the gradient to the curve gets less and less, and then there comes a flat line. The flat line that you see on the graph will represent the amount of gas that now the reaction is complete. The reaction is stopped because it moves in one direction. So the graph that best represents the the gas that is being released will be B, because there was no gas at the beginning, and then quite a bit of gas was released, and then the reaction stops. It's like when you're throwing cold drink into a glass and then you see the bubbles. And what happens to the bubbles? Slowly it gets less and less and less, right? You shouldn't be drinking cold drink. Okay, so D would be the best answer. So this is a typical exam question. It's a fair, it's not too difficult. It's actually a fair question to ask. You can ask a little bit more challenging questions in terms of stoichiometry. But with that, we will look at the discussion on how to do other sums now. So there's the answers that we've got. The reaction has reached completion. All the calcium carbonate has been used up. And B will be the best example of the gas of carbon dioxide that is being released. Okay, we'll stop there for now.